So what we're going to do in this lesson is kind of go back to one of the factors that you read about in the stability article yesterday. And that factor that we're going to focus in on was induction. Okay. And so what we'll do is we'll kind of go to a different worksheet where we'll remind ourselves what induction is, and then we'll kind of practice working with it just a little bit more. All right. So we'll start just kind of at the beginning and work our way to the bottom. So it says induction, otherwise sometimes called inductive effects, will often play a part in helping to explain how a reaction works in organic chemistry. Therefore, it's important that we spend some time kind of understanding it so we can keep it as a tool in our toolbox for later use once we get into reactions. And so first, just a reminder about what induction is. So what happens in induction is you either have electron donating or electron withdrawing groups that then affect the electron density in another region of the molecule. Essentially, it's all based on differences in electronegativity. And so let's talk about those two different types of groups just right quick. So our first group are electron withdrawing groups. And so the way these groups are put together is they typically have kind of a center atom and then outer atoms as well. For an electron withdrawing group, the outer atoms tend to be more electronegative, all right? So for example, fluorine is more electronegative than the carbon. And so since they have a higher electronegativity, they draw electron density toward themselves. This therefore kind of makes them take on a partial negative charge while leaving the center of the group partially positive. That partial positive center can then act as a withdrawer to take away electron density from other regions of the molecule that it's connected to, all right? On the flip side, electron donating groups often have a center atom that is more electronegative than the outside atoms. That center atom therefore kind of draws the electron density toward itself and takes on a more partial negative charge. It can then donate some of that extra electron density to other regions of the molecule. So first, what let's do is kind of spend some time practicing to make sure we can identify when something is electron withdrawing or when it's electron donating. So we've got some practice problems here. And what we're going to do is kind of look at these different functional groups that are attached to a benzene ring. And we're going to try to classify the groups as either electron withdrawing or electron donating. All right. And so what's going to be handy to have as you do this is kind of your functional group worksheet, because it kind of shows you the underlying structure of each functional group, and it's also going to help you practice naming them. So for example, CN, that's going to be called a nitrile group, and it's shown as a C with a triple bond to an N. And the R, that just stands in for the rest of the molecule, which in this case is a benzene ring. So let's go back and go ahead and name this. This is a nitrile group, and we represent it with a carbon triple bonded to a nitrogen. The nitrogen will need one lone pair because it only has 6 electrons, and that lone pair is needed to get it to 8. All right, now we need to assign partial negative and partial positive charges to our atoms. Nitrogen will be more electronegative than carbon since it's further to the right on the periodic table. It will take on a partial negative charge, while carbon will take on a partial positive charge. Now we have to decide if this means it's electron withdrawing or electron donating. The carbon is what's attached to the benzene, and since it puts the partial positive charge kind of next to the benzene, it's going to act as an electron withdrawing group. That positive charge will kind of help to take away electron density from the benzene and kind of move it toward that more partially negative nitrogen. All right, now let's go ahead and look at the next one. So here we have kind of a carbonyl compound, meaning you've got a carbon double bonded to oxygen, and it's got an NH2 attached. So if we go to our worksheet, we want to look in our carbonyl compounds, which are green. And so we're looking for one with NH2. Here we go. And this seems to be called an amide. So we'll go back and kind of name this functional group as an amide, and then we'll kind of sketch it out so we can see it a little better. So we've got a carbon double bonded to an oxygen. That will need 2 lone pairs. And then we have the nitrogen kind of attached to 2 hydrogens. And so it will also need a lone pair to fulfill its octet. Now let's go ahead and assign partial negative and partial positive charges. So oxygen is definitely more electronegative than carbon, and so is nitrogen. So carbon will kind of take on a partially positive charge, and the hydrogens are less electronegative than nitrogen, so it'll also be more partially positive. Now, the carbon is what's attached to the benzene molecule. If I could draw that a little more neatly. All right, and so that partial positive being attached to the benzene molecule makes this an electron withdrawing group. And what makes this group especially good at withdrawing electrons is it has 2 kind of highly electronegative atoms attached to that center. So kind of the electron density will be pulled toward the kind of through the carbon toward that oxygen and that nitrogen. All right, so now what you can go ahead and do is go ahead and finish these practice problems on the front, then kind of pause and check yourself with the answer key on Google Classroom and make any necessary corrections that you need to. Then once you've kind of done that, kind of restart the video and we'll go on to the next part together. All right, so let's go ahead to kind of this next part here. So it says now we need to make sure that we can apply kind of inductive effects to determine whether they will stabilize or destabilize a charge. And so kind of one important rule of organic chemistry is that opposite charges attract. So if you have negatives near positives, that's a good thing. And like charges repel. So negatives near negatives, not so good. Positives near positives, not so good as well. And so for positive charges, they will be stabilized by being close to negative regions. Since electron donating groups have a partially negative center, they will be able to donate that negative charge to make the positive charge more stable. On the flip side, negative charges are better stabilized by being near positive regions. So electron withdrawing groups have a more partial positive center that can draw away some of the negative charge to make it more stable. So our next instructions say for each of the following functional groups, identify it as either electron withdrawing or electron donating and decide whether they will stabilize or destabilize the adjacent charge. All right, so here, kind of in this first example, we have an oxygen and it has a negative formal charge. All right, so that negative charge is going to put it in the position to be an electron donating group. It has extra electron density that it could donate to someone else. Now, as a result, it's kind of adjacent to a positive charge, which means it will stabilize that charge. Oops, let me spell that correctly though. Stabilize. All right. So now let's look at this next example across the way here. So this is the nitrile group that we saw earlier, where nitrogen was more electronegative and took on a partial negative charge. Carbon was more partially positive. So because the partially positive carbon is kind of the connecting piece of that molecule, it will be an electron withdrawing group. But the good thing is that partially positive is next to a negative charge. So that will stabilize it by being able to kind of share in some of that extra negative electron density. All right. And then what you'll see is kind of a similar pattern where you get to practice that, kind of identifying whether it's electron withdrawing or electron donating, and then whether or not it will stabilize the molecule. And so again, go ahead and try the rest of those problems. And then the most important thing is you have to check yourself. That way you know if you're getting them correct, or if you need to stop, and ask for help or ask some more questions. All right, so good luck with the rest of those practice problems, and thanks for watching.